Okay. All righty. Trigonometry. Number 16. I'm going to read these in, no, just kidding. It's going to be, I'll tell you what I'm reading as I'm reading it, even though the key is dumb. All right, so the sine of j is 30 over 34, which is approximately equal to 0.88. And the cosine of j is 16 over 34, which is approximately equal to 0.47. The tangent of j is equal to 30 over 16, which is approximately equal to 1.88. The sine of L is 16 over 34, which is approximately equal to 0.44. The cosine of L is 30 over 34, which is approximately equal to 0.88. And the tangent of L is 16 over 30, which is approximately equal to 0.53. 18. The sine of j is 4/5, which is 0.80. The cosine of j is 3/5, which is 0.60. The tangent of j is 4/3, which is approximately 1.33. The sine of L is 0.60, 3/5. The cosine of L is 4/5, 0.80. The tangent of L is 3/4, which is 0.75. I'm going to stop reading the decimal ones just because. Oh, just kidding. It says it in the instructions, so I'm not going to stop reading the decimal even though I want to. Okay, number 20 is 2 times the square root of 5 over 5, which is approximately equal to 0.89. That's the sine of j. The cosine of j is square root of 5 over 5, which is approximately 0.45. The tangent of j is 2. Their answer is stupid, but it's 2. The sine of L is square root of 5 over 5, which is approximately 0.45. The cosine of L is 2 times the square root of 5 over 5, which is approximately 0.89. And the tangent of L is 1/2. 22 is the square root of 3, which is approximately 1.73. 24 is square root of 2 over 2, which is approximately 0.71. 26 is 1. 28 is 30.7. 30 is 23.2. 32 is 17.7. 34 is 24 inches, about. 36 is 33.7 degrees. 38 is 56.4 degrees. And 40 is 64.6 degrees. What questions do you have? 20? Okay. I don't know what that is. Is that Stephen and Ethan? I guess so. Number 20. We have this triangle. And it is triangle JLK. Or JKL or whatever. And side lengths are 2 times the square root of 3 and 4 times the square root of 3 and 2 times the square root of 15. And we're supposed to find the sine, cosine, and tangent of L and the sine, cosine, tangent of J. So starting with the sine of J, what is sine in opposites, adjacents, hypotenuse? Oh, you got a bloody nose, you need to get, here's a Kleenex. Oh, dry air. All right. What is sine in opposites, adjacents, and hypotenuse? Sine, what is it? No, opposite and adjacent's tangent. What? What is sine? Opposite over hypotenuse, true enough. Which length is opposite of J? 4 times the square root of 3, true enough. And then the hypotenuse, what is the hypotenuse? 2 to the square root of 15. Is it the square root of 15? It is the square root of 15. What did the key say? Oh no, this isn't that one. This is, okay, yay. Okay, good. So we need to simplify that. What do we need to do? Divide what? The 4s and the 2 or the square root parts? Okay, how do we divide that? There's a couple of different routes we can go to simplifying the square root part. Neither of them are division though. So what can we do instead? Multiply by what? No, that one's already on the top. He's fine. 2 isn't in a square root. Square root of 15. We could multiply by square root of 15. We could also simplify the square root of 15 first, but, well, not really, but kind of. We can go ahead and do this. We can also do 4 divided by 2. What's 4 divided by 2? 2. So we've got 2 over 1, right? And then square root of 15 times square root of 15 is what? No, 15. And then what's the square root of 3 times the square root of 15? True enough. Are there any perfect squares inside of 45? Okay, what are they? Or what is it? What? 5 isn't a perfect square. What are the perfect squares? Still no. You do mean 4. What else? Etc. One of those already goes into 45. Which one? 9 does. 9 times 1 is 45. What's the square root of 9?
3.
We can multiply the 2 times the 3, but we're going to be able to reduce the 3 and the 15. What goes into 3 and 15? What's 3 divided by 3? One. What's 15 divided by 3? 3 times 3 is 15? No, 15 divided by 3 is what? What times 3 equals 15? 5. Okay. What about the cosine of j? What is cosine in opposites, adjacents, and hypotenuse? Adjacent over hypotenuse. What is adjacent to j? 2 times the square root of 3, right? And the hypotenuse is 2 times the square root of 15. We already said that. So let's do this one similar but a little different. What happens to the 2 and 2 in the front? What? Yeah, they do, because what's 2 divided by 2? No, 0, it will all die. 1. So those are going to cancel and turn into 1, true enough. So in the bottom, what if we turned it into, instead of going ahead and multiplying by the square root of 15 on the top and bottom, what if we turn the bottom into the square root of 5 times the square root of 3? Because 5 times 3 is 15, right? Now what happens to those square roots of 3? They cancel out. So now we've got 1 over the square root of 5. How do we get the square root out of the denominator? Multiply by what? Not 15. Not 5 either. How do we say that whole number? Because it's not 5, it's what? Square root of 5. So times the square root of 5 over the square root of 5. Well, the square root of 5 times 1. Square root of 5. What's the square root of 5 times the square root of 5? 5. Cosine of j is square root of 5 over 5. What about the tangent of j? What is tangent in opposites, adjacents, and hypotenuses? Opposite over adjacent. True enough. What is opposite j? Square root of 3, yeah. 4 times square root of 3. And what is adjacent to j? 2 times square root of 3. What's going to happen to the square root of 3 over square root of 3? They're going to cancel. What's 4 divided by 2? It is 2. We would do the L ones the same way, right? And work all those out. Does that make sense? Do you have any questions about this particular problem? No. Okay. What other questions from this lesson do we have? 38. Okay. I already brought this eraser over. I guess I didn't. Maybe I did and then put it back. That wouldn't be unusual for me to do something silly like that. Use the calculator to find the measure of angle T to the nearest tenth. Okay. So, we're looking for angle T. So what are we going to use? You're going to use a regular trig function or an inverse trig function? We're going to use inverse. Inverse something. So 25 and 30 is where we have to figure out which trig function to use. What is 25 to t? Is it opposite, adjacent, or hypotenuse? Adjacent will be right next to, so it's not adjacent to the t. You mean opposite. That's probably true. So we've got opposite. What about the 30? What is it to it? Hypotenuse. True enough. So which trig function has opposite and hypotenuse? Sine. So we're going to do the inverse sine of opposite 25 over 30. Okay, so then we punch that in our calculator and push enter. And what do we get? Okay. So the measure of angle T equals 56.4 degrees. What? Oh, you just did sine of it. Nice. Any other questions from this lesson? 24, okay. Oh, it's on me. Like, who's coming in here? No, you're good. You're fine. All right, we're supposed to find the sine of 45 degrees using special right triangles. Okay, so if we're doing sine of 45 degrees, which special right triangle are we using? 45, 45, 90. True enough. I have the 45 degrees. So what's the ratios in a 45, 45, 90 triangle? One square root of true. Yeah. Okay, so sine is what in opposites, adjacents, and hypotenuses? Opposite over hypotenuse. So this equals 1 over the square root of 2. We need that square root of 2 not to be there. So what do we do now? Multiplying by what? Square root of 2 over square root of 2. True enough. What's the square root of 2 times 1? Square root of 2. What is the square root of 2 times the square root of 2? It is a square root of 4. What's square root of 4 equal to? 2. True enough. No, no, that's not what you said. You said square root of 2. Hi, remember me, sir? All right, I don't, actually. I apologize. But welcome back. So sine of 45 is the square root of 2 over 2. So you can get the special ones using the triangle, always. That's a way to do it. I'm going to show you another way that kind of is going to lead towards pre-cal. And the reason I'm showing it to you is because you can get there just by counting to 4. And so it might be an easier way to remember them, all of the things. Yeah, so let me show you some special things real quick, and then we'll move on to the next lesson. So we're going to make a little chart that's the sine of theta in the first row, and then the cosine of theta, and then the tangent of theta. We're going to list some that we don't know yet, and it's easier to know these once you learn how to graph trig functions, but we're not going to cover that in this class. But I'm just going to give them to you, because you understand the numbers 0 and 1, so we got this. All right, so we're going to list up at the top, we're going to list 0 degrees, and then we're going to do all the kind of special angles in numerical order. So 30 degrees, 45 degrees, 60 degrees, and then we're going to round out our list with 90 degrees. Okay? So the sine of 0 degrees, I will tell you, is 0. You don't have to worry about why that is. It just is. The sine of 30 degrees would be from a 30, 60, 90 triangle, right? We got the 30-degree angle over here across from the short leg. And the 60-degree angle over here, we got 1 and 2 and the square root of 3. Right? So the sine is opposite over hypotenuse, so 1/2. The sine is 1/2. We just looked at the sine of 45 degrees is the square root of 2 over 2. Now, for 60 degrees, the sine would be opposite over hypotenuse, so the square root of 3 over 2, right? Now, this is the point where our 0 through 4 gets a little bit silly. Sine of 90 degrees is 1. You can write that as the square root of 4 over 2, right? Because the square root of 4 is 2, and 2 divided by 2 is 1. 1/2. Yes, your voice is echoing. Yeah, it's this room. I apologize. It's a little bit, the acoustics aren't great. So sine, if we list them in order, goes 0, 1, 2, 3, 4. Cosine is exactly the opposite. Cosine of 0 degrees is 1, or the square root of 4 over 2. The cosine of 60 degrees is the square root of 3 over 2. Square root of 45 is where they meet, and they're the same, right? Square root of 2 over 2. Cosine of 60 degrees is 1/2. And the cosine of 90 degrees is 0. Right? So that gives a sine and cosine. Sine goes from 0 up to 4. You can also get it from the triangle. Cosine goes from 1 down to 0.
Tangent, it's useful to learn an identity real quick to figure out tangent, because the only ones you have to actually memorize if you use this chart method are these two. You can build these ones and the other three, which you're not going to learn this year, just from these two. Because you'll learn later that the tangent of theta equals the sine of theta over the cosine of theta. So what's 0 divided by 1? Zero, true enough. And what's 1/2 divided by the square root of 2? How do we divide fractions? Not opposite reciprocal, just reciprocal, but yeah. So 1/2 divided by square root of 3 over 2. What's gonna happen to the two 2's? They're going to cancel. We've got 1 over the square root of 3. We've got to rationalize it, and it'll turn into the square root of 3 over 3. What's square root of 2 over the square root of 2 over 2? Those are, and I should emphasize that those are the same, right? So any number divided by itself is always equal to what? No, not 0. 1. This one we got square root of 3 over 2 over 1/2. So the square root of 3 over 2 divided by 1/2. What's going to happen to the two 2's? Cancel. So we've got just square root of 3. Now we get a little bit of an interesting thing because we've got 1 divided by 0. What's 1 divided by 0? Try it on your calculator, see what happens. What does it tell you? It tells you you can't do it. You can't divide by 0. It's undefined there. So whether you memorize it this way or you memorize it that way, you'll need to know all of those. You'll need to know how to do those without a calculator. Okay? Let's learn the law of cosines and the law of sines. 8-6. So up until now, really the one lesson, we've learned about trigonometry. We have said that trigonometry goes with right triangles, which is true. You can only do trig on right triangles, except that's not quite true. If we want to find missing things from not right triangles, we have to use one of these two tools. We have to use either the law of sines or the law of cosines. Okay, so the law of sines and the law of cosines are both for non-right triangles. Now, you could technically use it with a right triangle, but you don't really have to waste your time. And it is useful, I think, I'm going to write these in letters, but I want you to kind of think about it differently. And I want you to think about it as paired up sides and angles. H. See? Because if we do this in an actual problem, actual example, whatever, that you won't necessarily have these same letters and whatever else. And it's also much more difficult to memorize, especially the law of cosines, if you think about it as A, B, and C. If you think about like these two are paired together, then it doesn't really matter whether it's A or B or C or any of those things. So I hope that makes sense so far. So the law of sines says, why did it, oh, just kidding, they didn't. Okay. The law of sines says that the ratio between the sine of the angle and the opposite side are all congruent. So the sine of A over side A equals the sine of B over side B, and the sine of C, it equals the sine of C over side C. Those are all equal, so they're proportional, basically, right? Now, you use law of sines. Law of sines is the simpler of the two relationships, the simpler of the two formulas. Just you're going to just set up a proportion and roll with it. That's how you're going to use law of sines. We've been doing proportions for a long, long time. All right, so you want to use law of sines if you have an option. We can only use law of sines if we know at least one pair. So if we know an angle and its opposite side, any one pair, we can use law of sines. If we know any one pair and we know something else, we can find everything else. Ow, that was silly. Okay? But if you have at least one pair, you can go for it. But so if you knew all of the sides, you couldn't use law of sines. Or all of the angles, you couldn't use law of sines. Okay. Law of cosines lets us do that one. Now, law of cosines is where it's going to look confusing. We're going to write 3 versions for this one. Kind of like we wrote 3 versions for this one, but it's going to all go together. Now, so this is really where what I was saying before, you need to take into account, because if you just look at it in letters, it's going to be really hard to memorize. So law of cosines says that a squared equals b squared plus c squared minus 2bc times the cosine of angle A. Okay, you're like, what the heck? That's a lot. It's going to be hard to remember all the things. Notice what I said before. If you think in pairs, you can get it. So the side and this opposite of the angle over here are the ones where it's cosine and the one by itself. And then these are just the other two sides. Other two sides squared minus 2 times the other two sides. So we write that in kind of terms of B, the B pair. Then the side by itself would be the B squared, and then the other two sides are A and C, so A squared plus C squared minus 2 times same, A, and then C, and then which angle would go in here and go with the one that goes with this one. So then the one in terms of C would be C squared equals the other two sides squared. So A squared plus B squared minus 2 times same, A and B, times the cosine of the angle that goes with this one, so C. So you're going to use this one if you can. And that's if you know a pair. If you don't know a pair, you got to use law of cosines at least once. Okay? Let's do some examples. What? Okay. You're done with law of sines though, right?
So let's do a couple of these. So we know those aren't right triangles because we solved for the third angle on both of them. We wouldn't get 90 degrees, so they're not right triangles. So we can't use just normal trig to get to solving for x. Right? So we've got to use something. So we need to ask ourselves, do I need to use law of cosines or can I use law of sines? Well, in this triangle, we've got a pair. We've got this angle and this side across from it. And if we have that, we can use law of sines. So that it's easy peasy. Sines on the top, sides on the bottom, right? So the sine of 78 degrees over 8 equals the sine of 60 degrees over x. Now we've got a proportion. We can solve this easy peasy. So what do we do to solve this proportion? What? We do cross multiply, true enough. So x times the sine of 78 degrees is x times the sine of 78 degrees, right? Eight times the sine of 60 degrees for now is 8 times the sine of 60 degrees. We try to keep things exact until the last minute, because then we don't introduce extra rounding errors. So that sine of 78 degrees is right next to the x, so how is it attached? Addition, subtraction, multiplication, division, or something else? How is the sine of 78 degrees attached to x? It is multiplied. How do we get rid of it? We do divide it. So we're going to divide by sine of 78 degrees. Sine of 60 degrees, we don't even need a calculator for technically. It's square root of 3 over 2, which is going to be irrational. So now we're going to punch that in our calculator. We're going to get an ugly decimal answer, and we're going to round to the nearest tenth. That's not what this says. Did you do 8 times the sine of 60 degrees divided by the sine of 78 degrees? Okay. $7.1. All right, let's do this one. So, do we know a pair? Yes, we do. We know this 8 and this 54 degrees. Good to go using the sine. Why did they make this like the same type of problem as the other? They should have done one where you're finding the angle. That's fine. Okay. Where am I? What am I doing? Actually, we should scrap this and do a different example. Hold on. Let's do a different kind of looking one, because doing the same idea is useless. Let's go to homework things, and let's do that one. Oh, I'm just kidding. That's law of cosines. Can't do law of sines on that one. Do they not have any that are like that? What the heck? That's crazy. That's crazy talk. Fine, we'll make one up ourselves.
Good luck to us.
May the odds be ever in our favor.
Let's erase the numbers. Make something else useful. Okay. YOLO. Let's say that this is in fact 88 degrees, and this is 12. X is right here, and this is, how about 9? Okay, so we're supposed to solve for X degrees. X is the angle this time. So we do know a pair, we're going to jump to the law of sines. So the sine of 88 degrees over 12 equals the sine of x degrees over 9. I didn't actually do the math in my head real quick to make sure that the numbers I gave even can make a triangle. We'll hope for the best. See what happens. All right, so what do we do now? What? Cross multiply. True enough. Okay, so we've got 9 times the sine of 88 degrees equals 12 times the sine of x degrees. So what do we do now? Divide by 12, right? So the sine of x degrees equals 9/12, which would reduce to 3/4. Oh, times the sine of 88. Cart before the horse. Now, in order to finish this one out, we're looking for an angle, so we're going to end up using the inverse, right? Ultimately. Let's go ahead and get a decimal equivalent for this in our calculator. So 3 times the sine of 88 divided by 4. $1.12. Uh-oh. Okay, so to get this and find this x, we need to find the inverse sine of this. So the inverse sine of 1.12 is going to be approximately equal to what? So if you remember in your calculator, you can grab that number without having to retype it, right? So you can do the inverse sine, and then you do second or shift, and then you hit answer, and it'll like paste that in there, and then you can push enter. What? Oh yeah, did you do it right? Let me make sure you did it right. You did. Pretty sure you did it right, but let me make sure. I actually didn't, that's crazy. Yep. Clear. That's why I said uh-oh. But I want to do it myself just to make sure of a sanity check. Divided by 4. Enter. Wait. 3 times the sine of 88 over 4 is not 1.12. Are you in degrees? Yes, you're in degrees. Because when I punch the 3 times the sine of 88 divided by 4, I get 0.7495, etc. So double check what you put into, see if you get the same thing. See if there's something about the way we're plugging in stuff that is inaccurate. You didn't close the parentheses, so you accidentally did 88 divided by 4 probably.
3 times the sine of 88 divided by 4. Yeah, I think it's 0.75. Which is not an uh-oh. Okay, so once we have that, then we can hit inverse sine of the answer, enter. 48.6 degrees. What? I'm tripping, bro? I don't think so. I think you're tripping, bro. What'd you get? No, you got to do the first thing. So 3 times the sine of 88 divided by 4. Good. So you got that back in there. Good. No. Oh. What the burger? Okay. 48.6 degrees. We did it. Look, Mom. Okay. So, how we doing? Good enough. Not great, but good enough. All right, let's do another problem. One in which, oh no, we don't have a pair of things. It's not actually that bad. It just kind of looks a little scary. Okay. So, what do we have a triangle like this one? Got X. We've got 28 degrees. We've got 11, and we've got a 9. So, oh no, we don't have a pair. The only angle we know anything about is 28 degrees. And he goes with X. So we don't know a pair of them, so we got to use law of cosines. So to figure out how to use law of cosines, we need to look at the pair of things that is involved. It's going to have a letter in it, but this is the pair that's involved. This is the one that's going to be on the outsides, right? So it's going to be the side squared equals all the other stuff, right? So it's going to be x squared equals, and the other two sides squared, so 9 squared plus 11 squared minus 2 times the other sides, so times 9 times 11 times the cosine of our angle. Now we can start working it out. What is 9 squared? 81. What's 11 squared? 121. Plus 121 minus, what is 2 times 9 times 11? 198. That's the cosine of 28 degrees. So what's 81 plus 121? 202. So we've got 202 minus 198 times the cosine of 28 degrees. So we can show all of this in our calculator. We're going to get a weird decimal, leave it in as an answer because we're going to do one more thing with it in a minute. $198, yep. Well, that's what you told me. I didn't double check it. So what do we get right there? 25.2-ish. So get rid of that squared. What's the last thing we got to do? Yeah, that. We got to square root it. So x is approximately equal to what?
5.2 is what the key says, but maybe so. What?
Okay. Okay. We got time for like one more example. Make sure there's not anything I am missing before I do this one. No, there's nothing I'm missing. All right. So we're going to do a problem that says solve the triangle ABC. What that means is find all of the missing things, sides, angles, whatever is missing in the given. Okay. So we're going to have this triangle, A, B, C. And side B is 10.2. Side C is 9.3. And side A, or excuse me, I lied. Angle A is 26 degrees. Okay? So the instructions say solve the triangle. So what it means is find all the missing things. So we need to find angle B, angle C, and side A. Right? We find all those things, we got it. Now we don't know a pair yet. So we go to law of cosines. Right? So the group that goes together will be this 26 with this side CB. Right? So that's the ones that are going to go together on the ends. So the side squared, so the measure of, in fact, I'd say the measure, let's go ahead and label this as side A. That's what it would be. It's going to make our life a little easier, right? So it's going to be A squared equals B squared, B is 10.2, plus C squared, so 9.3 squared, minus 2 times these ones, so 10.2 times 9.3 times the cosine of the angle. You know, we took all that time to write all that down. I have enough time to course correct because this example is so much like the other one that it's less useful. I'm going to change my mind. I'm sorry. We're still going to do something with law of cosines. We'll go ahead and even add you an extra thing in this book. Let's go ahead and put a number there for the side instead. So let's give us no angles. This side length is 4.5. I don't usually do this in this book, but they very definitely didn't draw their picture to scale. They wanted you to do some math. All right, so again, we don't know a pair. And we don't really know which angle to start with, right? So it doesn't really even matter, like which ones are on the outside. Which one do we want to start with, A, B, or C? Doesn't matter. B sounds great. So we're going to do these on the outside. Okay? So we're going to do 10.2 squared equals the other two squared, so 4.5 squared plus 9.3 squared minus 2 times the same as these. So 2 times 4.5 times 9.3 times the cosine of the angle that goes with this one, right? So the cross of the 10.2 is angle B. So the cosine of B. And we're looking for an angle, so eventually we're going to use the inverse cosine, right? So what is 10.2 squared? What's 4.5 squared? 20.25.
What's 9.3 squared? And what's negative 2 times 4.5 times 9.3? $83.7 sounds correct to me. Times the cosine of B. We can combine the like terms, right? This one and this one. This one isn't alike because it's got this mess on it. So what's 20.25 plus 86.49? $106.74 minus 83.7 cosine of B. So how do we get rid of this number? Subtract it. True enough. Minus 106.74. Minus 106.74. We end up with negative what? Negative 2.7. Negative 83.7 cosine of B. How do we get rid of this negative 83.7? Divide. True enough. What is negative 2.7 divided by negative 83.7? It's positive. Three. Okay. So then what is the inverse cosine of that? There's no way that's right. Brother. What the burger? 2.7 divided by 83.7. Enter. 1 over 31. Why did you say that? That would have been easier. Then the inverse cosine of that number. 88.2. Brother. 88.2 degrees. Now we know a pair, right? We know this is 88.2. We can now use law of sines to finish it out, right? Because we can continue to use law of cosines. In fact, that would arguably be the best practice because we're always going back to original numbers, and if we made a mistake on this one, we don't compound our error by reusing this number. But you can use law of sines. So you could use either one to finish out this problem, right? Plug in. I won't necessarily walk through it because we don't really have time, and it's fine because we've done law of sines problem. We can do the sine of 88.2 degrees over 10.2 equals the sine of A over 4.5. And then we could solve that just like what we've done the other ones, right? And you could do the same thing for C, or you could use law of cosines again. It doesn't matter at that point. The safest would be to use the law of cosines to find all three, because then if you make errors, you don't compound the errors. But either way will get you the answer as long as you don't make mistakes. So the homework is on page 593. And you're going to do numbers 12 through 28 evens. All right, I will see you after spring break.